All right, so let's get started. So today we're going to be looking on bearings. Yesterday we looked at trigonometry. We looked at some problems. And tonight we're going to see how best we can tackle these types of problems, all right? Now we're kind of continuing from trigonometry. And in the same way that we looked at how to solve a trig problem, we want to look at how to solve a bearings problem, all right? So you remember I said keep the trig rules in mind. So you know that mostly when we're working with bearings, a lot of the times it's with non-right angle triangles for the most part. So I would definitely say those are the things that you have to keep in mind. But when solving a bearings problem, we can take two approaches, right? Because we know we're dealing with triangles. So we can either look at the angle or we can look at the side. So just jog my memory. When we're dealing with bearings, what rules, what in trigonometry applies, especially for non-right angle triangles? What do you think we can look for? What do you think we can think about? It comes to your mind. All right, yeah, it's a sine rule because we know we're dealing with those, or the cosine rule, and those kind of go hand in hand. Once you can use the sine rule, then you can use the cosine. Next, so these can be used to find either an unknown side or an unknown angle. Now, on the other hand, we know that we'll have our when we're dealing with angles. So you know what I should have done? Let me put it out like the two basically. So either we're looking at angles or we're looking at sides. We're trying to find an unknown side or an unknown angle. If it's an unknown side, we can use one of the rules. So that's the sine rule, cosine rule, or depending on the triangle, anything that can apply. Because sometimes in these problems, you'll see it's like this is at to the east or to the west, and that can give you an idea of what to sketch. If we're dealing with angles though, how could we solve bearing problems with those? Well, we can still use the sine or cosine rule, but we can also make use of some angle properties. So those are pretty important. And that can help us, especially with the way that the diagrams are set up. You understand? So that's pretty that's pretty important. So when we're dealing with angle properties, we look at the sine and cosine rule yesterday. But with these, what are some angle properties that come to your mind? What angle properties do you remember that you can share with me? All right, so I'm seeing here Ninja saying alternate angles. Yeah, that is one that comes. So we need to know stuff like let me start a little with a little easier one. No, this one. Angles on a straight line, sum to 180. So if this was X and this was Y, then X plus Y is 180 degrees. Good. Next, let's put in those alternate angles, or what some people they like to call them Z angles. Okay, let me do that here. So we know here, if I have an angle here and an angle here, if this was X and this was Y, then X is equal to Y. Yeah, good. Vertically, nice. Keep them coming. Vertically opposite. That's another one. So if this is X and this is Y, then X is equal to Y. Vertically opposite angles are equal. That's another important one. Let me look in the chat now. Corresponding. Yeah, that's another one. So we know that if we have two corresponding angles, and those are what people like to call the F angles. So if I had this being X and this being Y, that don't look so good. Let me draw it nice. So that's X and that's Y. Then X would be equal to Y. Let me look in the chat to see if I see anything else. Co-interior. Now that one is the one that I would say is, so based on what I've seen, it comes a lot. So it's really good to know those. So co-interior angles. Remember that we say here, if we have two angles like this, then they will sum to 180 degrees. So X plus Y equals 180. In other words, co-interior angles are supplementary. Right? So that's another one. That's another one. Right? Anybody else remembers? Any more? All right, that's it. I think it's safe for us to put the one for 362. Angles at a point sum to 360. So if I had, let's say I had a point here and I had like these, then if I had the angles X, Y, X, Y, Z, it should be W, X, Y, Z. Yeah, W, X, Y, Z. Then W plus X plus Y plus Z is equal to 180. And that's another one that's important. So these are some of the things that we have to know about. We really need to know about these in solving our bearings problems. All right. So as we go along, we're going to be thinking about these. Generally, for me, I kind of like to think about bearings start with the angles first. So anytime I meet on a bearings problem, I'm thinking about what do I know if I want to figure out an angle. So I'm thinking about the angle properties. And if an angle property don't work, then I'll move to the sine and cosine rule. But if I know I'm looking for a side, then most likely somebody, probably a trig ratio or the sine rule and cosine rule is going to come out. You know, so it's kind of like a process where you can think it through. Now, another very important thing that we want to know about bearings, or we must remember the definition of a bearing, and this is also another problem that happens each year. So remember that a bearing is an angle measured clockwise from the north. It always has to start at the north and it always has to go clockwise. Okay. So if I have, let's say I have a spot here, A, and I have this other point B, then the bearing of B from A, so B, oops, the bearing of B from A means that I am going to start at A. I am coming from A. Right? Just like if you're going to school from your house, that means you start at your house to go to school. Likewise, B from A means you start at A to go to B. Yes, son? So that means I'm going to put my north line at A because remember, it's clockwise from the north. Zin. And then I am going to measure the degree or I'm going to measure the angle from clockwise, as we said. So here it would be this angle. Put it in yellow. This angle. And so this angle would represent the bearing of B from A. So always remember that it's clockwise from the north. Once you remember that for a bearing, then you can't go wrong. You always know where to start. It's not always just an angle. Now, let's keep these things in mind as we go along. So let's get ready to jump into some CXC problems. Am I missing anything out? I don't think so. Do you guys have anything that you want to throw in here that we should remember? I don't think I'm missing out anything. I'm not sure. No, I don't think so. I think we've covered everything. By the way, just so we know what pace we're going to move at, how comfortable are you with bearings? On a scale of 1 to 10, write that for me. Where would you put yourself with bearings? Let me look out in the chat. All right, hey, nice. All right, 8 out there. Say 8, good. So that's a 5. Yeah, I don't think I'm missing out anything, Christine. I don't think so. I don't think so at all. I'm seeing a. Okay, all right. So we got some 9s and some 8s and some 6s and some 5s. So no worries, no worries, no worries, everybody. So that means we can kind of move. We'll work them. But as usual, if there's something that you're not getting, remember, let me know so that we can stop and we'll make sure say you're good. All right. So let's jump into our first problem. Remember, the formula sheet is always here for you. Intrigue when you're thinking about the sine rule and the cosine rule. It comes on your exam. Now, in this first problem, it says a ship travels from Akron A on a bearing of 030 or 30 degrees to Belleville B, which is 90 kilometers away. It then travels to Compton C, which is 310 kilometers due east of Akron A, as shown in the diagram below. First, we want to indicate on the diagram the bearing of 30 degrees and the distance is 90 kilometers and 310 kilometers. Want to calculate to the nearest distance, nearest kilometers, the distance between Belleville and Compton, and we want to calculate to the nearest degree the measure of ABC and the bearing of Compton from Belleville. So let's get started. First, we want to show the bearing 30 degrees and the distances on the diagram. So what do we know? It says the ship travels from Akron on a bearing of 30 degrees. You remember what a bearing is? Bearing is clockwise from the north. So I have to start you have to start at the north and then go round clockwise. So it says from Akron. So that means we're starting at Akron, going clockwise from the north until we reach the Belleville. So when I do that, that means this is going to be our bearing of 30 degrees. Right? Everybody clear with that one so far? So because it says from Akron, it means we start at Akron and then we go to Belleville. What else do we want to put on? It says that ship, on that bearing, it's 90 kilometers away. So that means, we know that that's the distance from Akron to Belleville. So this is 90 kilometers. Boom. All right, there, so. All right, what else? It says it then travels to Compton, which is where? 310 kilometers due east. And 310 kilometers due east of Akron. So what does that mean? Because it says it's due east, that means from Akron, we're going to look to the east. Like we're going to look directly to the right. Yeah. So that means this distance down here is what is going to be 310 kilometers. All right. So we have indicated those things on the diagram. Everybody good with that one? I think I'm hearing somebody talking. I'm not sure. Oh, that's just me. Yeah. All right, good. Now let's look at the next part. It says, calculate to the nearest kilometers the distance between Belleville and Compton. So we need to figure that one out. So let's first identify the distance between Belleville and Compton. That's the line BC. So that would be this line over here. So this is the distance we want to find. Now, what do we know? What are some things that we know? We know that this bearing is 30 degrees and Compton is due east of Akron. So that can help us with some info, you know, because if Compton is east of Akron, so we have the north here and we have the east over here, then that means this angle between the north and the east must be 90 degrees. Yeah. So that has to be 90 degrees because it's north and then it's east. Yeah, that looked like it. Huh? So in that case, if the whole thing is 90, that means this angle BAC, this little angle right here, is going to be what? Who can tell me what that angle is? What is that little angle right here? So 60 degrees. Yeah, good. Great job. Great job, Christina. So that's going to be 60 degrees. Now let's look at what we have. We want to figure out a distance. We want to figure out the length of a side. So you know what? Automatically, we're thinking either the sine rule or the cosine rule. So now, which one would you use? Would you use the sine rule or the cosine rule? Let's look at it. Let's look at what we have. We have two sides, yeah, and we have an angle between them. So once we have two sides and an angle between them, I want to find the side that is opposite to that angle. Remember what I said yesterday? Like you look for the little arrow, you follow the arrow. So we have our little arrow that's pointing here, so we know we're going to use the cosine rule, yeah? So once we have those two sides and the angle between them. So now, that means if I fill that out, right, then the side that I want, BC, so BC squared, is going to be equal to the square of those two sides. So that's 90 squared plus 310 squared minus 2 times those sides. So that's 90 times 310 times the cosine of 60. That is the angle that's between them. Okay. So that's our distance BC. See? So let's just throw that straight in the calculator. So watch me now. Watch me now. What do I want? I want the calculator. Oops. I didn't have this thing loaded up. There's more. Carrot over here. So, oh, you guys not going to see it. Yeah, supposed to cancel the calculator. So now I'm just gonna throw that straight into the calculator. So what's that now? That is 90 squared plus 310 squared minus 2 times 90 times 310 times the cosine of 60. And again, guys, this is why I tell you, it is so important to have a good calculator. You can just put it in there. So now that is, you see the answer, 76,300. So BC squared is 76,300. So that means we can solve for BC, that distance, because it's going to be equal to the square root of 76,300. And what is that? I think I see somebody in the chat saying, I think, who that? Ninja saying 276. Let's see. Is it 276? Let's check it out. So square root our answer. 276.22. I wanted it to the nearest kilometer. So yes, 276 kilometers. Right? 276 kilometers. Yeah. So that's what we would use. So I'm thinking the side. So I use either the sine or cosine rule. Now let's go down to the C part of the question. Calculate to the nearest degree the measure of angle ABC. So let me carry ABC with me. So I'm doing the Robbins. So this, that is 60. Check this out too. All right, so that is 60 degrees here. Hold on 1 minute. Yeah, sorry about that, guys. So angle BAC. So let's cut that here. And let me go down here. So I want BAC. So first, ABC, sorry, ABC. So let's identify ABC. So let's write on what we have already. What do we know? We know that this side is 276 kilometers. And now we want ABC, which is the angle that's right here. ABC. So now let me hear from you. We're thinking about an angle. What do you think we can use? Do you think we can use the angle properties, or would you use the sine or the cosine? Let me see. Let me see what you guys are thinking in the chat. What you guys thinking? Let's see what you're thinking. What you're thinking here. So now look at what we have. Look at what we have. Look at what we have to help you to figure it out. What do we have that's going to help us? So this is one of the, oops. Sorry guys, some nice I didn't expect. We could, and this is one of the cases where we could use the sine rule, or we could use the cosine rule. If you look at it, so we have three sides. We have the sides and the angle between them, and we also have a pair of sides that we could use. We wouldn't necessarily use the property, because if we were to use the property, even if I were to figure out this angle, I don't have enough information to figure out this one over here. So it would probably be best to use either the sine or the cosine rule. I'm going to use the sine rule. Now remember, the sine rule says the sine of an angle to its opposite side is the same all throughout. So that means the sine of, because I know this pair. I know that angle and I know that side. So the sine of 60 to 276 kilometers is going to be the same as the sine of B to its opposite side. And where is its opposite side? At 310. All right. So I can use this to help me figure out the value of B. So now let's try that. So like yesterday, let's just throw it straight in this time. Let's just throw it straight in. So that means sine B to 310 is going to be equal to sine 60 to 276. And I want sine B by itself. So I can multiply both sides by 310. So sine B is going to be 310 sine 60 divided by 276. And then just to make sure we get that exact answer, before we even work it out, let's just throw that straight into the calculator. So let's just put that straight there. Let's just find the sine inverse of all or whatever that is. Yeah. So that means B is going to be equal to sine inverse of all of that something. 310 sine 60 divided by 276. All right. Everybody with me so far? Everybody with me? Yeah, no, maybe. Seeing that, right? Okay, good. Great. So let me get my calculator. I'm having a little I don't know what's happening with my screen here. Just give me a minute. Okay, all right. Supposed to good now. So now we're going to have sine inverse. So that's sine inverse of what is that? Let's put we have our fraction. That's 310. I see some people in the chat saying they get 77. So let's check if we get the same. 310 sine 60 over 276. And yeah, that's what we got. 76.58 to the nearest degree. So it's going to be 77 degrees. All right. So that means B is 77 degrees. So we can say, therefore, ABC angle ABC is equal to 77 degrees. All right, no, guys, we're on to something. We're going on good. We're going on good. So now, what else do we need? Let me take back the original diagram here. So what else do we need? Let's cut this and copy this. So we just figure out the angle ABC. And now let me put in that information. Oh, this question is, this part of the question is 3 marks, by the way. So we figured out this is 276 kilometers. We figured out that this is 77 degrees. Now, what do we want? We want to find the bearing of Compton from Belleville. So what is that? What's the bearing of Compton from Belleville? So let's start now. When we say it's from Belleville, that means we're starting at Belleville. So we go to Belleville, clockwise from the north, all the way to Compton. So when we do that, we realize that it is this angle. So this is the bearing of Compton from Belleville. All right? Christina, CXC, you get 11.3. Just seen that one. From when? That's the question that we just did. Oh, that's not there. That's a little off. That's a little off. And then when you look on the angle too, you can see. Yeah, okay, you get it now. Good. So, right, we can use the property. How could we use angle properties here to help us to figure out that bearing? Well, essentially, we just want this angle here. We already have a part of it. We already have an angle near it, 77 degrees. But what about this angle? What about the one right here? If we can figure this out, then we can take both of them from 360 to figure out that bearing. So the question is, what is that angle going to be? Now we can think of our angle properties. What helps, you can probably trace on the diagram. So let's trace it out. So here, what if I did a little trace out something like this, right? And here, notice that this angle, these two angles are what? Corresponding. See? Can you notice corresponding angles? Corresponding angles usually between two parallel lines here and here. See? So since not corresponding, sorry, co-interior. So since they are co-interior, then both of them sum to 180, and that angle right here must be 180 minus 30, which is 150 degrees. So since we know that this is 150 and this is 150 and this is 77, then we can figure out that unknown angle by subtracting it from 360. Okay? So let's do that. So let's do that now. So here, what do we know? Let's put that in red. So the bearing from Belleville, from B to C, is going to be equal to 360 minus that 150 and 77. Now 150 plus 77, that's 227. So that's 360 minus 227. And 360 minus 227. You know, like when normally you could add it in, like when you're doing the maths, normally you can just add it in your head. But then when you're on the exam in your calculator, you're putting in like 1 plus 1 is 2, because you just want to make sure it's so I feel right now. But I think I know that this is 133. Somebody just verify that for me. I think I know that this is 133. From what I'm doing in my head. are at 83. That is, you know what, probably better. 133, right? Yeah, good. 133. Don't tell anybody say I couldn't do that. So the bearing of Compton, so therefore we can say the bearing of Compton. Okay, now you have to write it properly for the CXC. Bearing of Compton from Belleville is 133 degrees. Okay. So that would be our solution. So here we realize all of the different things that kind of came into play. Does anybody have any questions? Any part that not so clear on that you just want us to look on, or everything good so far? What do you say? You can either write it in the chat or you can open your mic and ask, no problem there. All right, sound like everybody good? Sound like everybody good? So guess what? Now let's go. Let's go to the next question. All right, now this question was from last year. This was a question from last year, 2021. From a harbor H, the bearing of two ships, Q and R, are 69 degrees and 151 degrees respectively. Q is 175 kilometers from H, while R is 242 kilometers from H. And we see we have an incomplete diagram here again. So we want to first complete the diagram to show the information given, calculate the side QR, and then calculate how far due south is ship R of the harbor H. So let's start by completing the diagram above. So look at it very carefully. Look at it very carefully, and then we're gonna put what needs to be put where. So look at it good. Let me just look at it good. So I'm just giving you a minute just to look at it, just to make sure that we're good. Look and see if you have it at the right place. No, let's see if we can try filling out. Let's see if we can try filling out it here. So, share again. First, it says the bearing from H. So we know whatever we're dealing with, we're going from the harbor H. And it says the bearing of two ships Q and R are 69 degrees and 151 degrees respectively. Q is 175 kilometers from H. So we know that this is 175 kilometers. Then, and what else do we know? It says R is 242 kilometers from H, which is already shown on the diagram. What's missing? How about our bearing? It says from H, the bearing of two ships Q and R are 69 degrees and 151 respectively. So R would be on a bearing of 151 degrees from H. What does that mean? It means that we start at H and then we go all the way around to R. So it means that all of this would be on a bearing of 151 degrees. Cool? So I can kind of draw it out completely like this. Or what we could do is that we can realize if the whole thing is 151 and then this part is 69 degrees, that means the rest of it is going to be 151 minus 69, right? Because we can figure out that little angle that fits in the space. So when we do that here, we realize that this angle, this little part here, is 82 degrees. So we can write that here. So, and so we know that that is 82 degrees. Just to be safe, I'm also going to put that all of this is 151, just to be safe. Because they say show the information given, and the information given is about the bearing of 151 degrees. So I'm just putting that there. All right. Now it says calculate QR, the distance between two ships to the nearest kilometer. So let's look at our information. We want QR, okay, which is going to be right here. So that is QR. I want a side. So when I think in sides, I'm thinking either one of the trig ratios or the sine rule or the cosine rule. It's not a right angle, so I know I'm going to have to use one of the rules. Which rule would you use here? Which rule would you use to find QR? Let me see what you're thinking. That's right, the cosine rule. Good, yeah. Because we have, again, we have two sides. Let me highlight it. We have two sides. We know two sides and we know the angle between them. Right? So let's do that. For this one, I think I can, let's just label it still. I didn't label the last one, but you know, it doesn't hurt. So we know that this would be H because it's opposite to capital H. Likewise, this would be Q down here because it's opposite to Q. And up here would be R because opposite to R. So that means the side that I want, QR, which is H squared, it's going to be equal to the square of the other two sides, R squared plus Q squared minus 2 times those sides RQ cos the angle between them. So that would be cos H. So now let's work that out. We know H is QR, so QR squared is equal to 175 squared plus 242 squared minus, 242 squared minus 2 times those numbers times the cosine of 82, the angle that's between them. So now where we're going now, right? Let's get our calculator. So now we're going to put that in our calculator. So what's that now? 175 squared plus 242 squared minus 2 times 175 times 242 times the cosine of 82. And that's 77,401. Yeah, that works. 77,401. So we can put that there. So that's going to be 77,000 that. And who can tell me what QR is going to be, if that's the case? What is QR going to be equal to? I see some people saying 278 to the nearest kilometer, and I think I'm going to agree with that. Yeah. I think I'm going to agree with that. Yeah, 278 kilometers. I want it to the nearest km. Okay. All right, good. So boom, we find QR. Walk with the diagram now. We get the diagram and thing. So now the next thing that the question wants us to find, let's just get it in a few. So I want to count next. It says, and I like this question. You know, I really like this question because it challenges sometimes where you say, just do this or that, because maths is not just do this or that. You really have to think through what the thing is saying. And we're going to see that here. So I want to calculate how far due south is ship R off the harbor H. Now, when it says how far due south, what does that really mean? Well, if we have our north line, then for it to go south, which color I don't use it? I use green, so I'm going to use blue. If we're going to go south, that means we're going to go in this direction, okay? Opposite to north. And basically, we want to know how far due south is ship R off the harbor H. So in other words, if I were going, line keep leading up. Sure. Yeah, all right, that's good. So if I were going south, then it would be in this direction. Right? And what do I know? I know that R is over here. Okay. I know that R is, okay, don't meet up so properly, but don't know. Yeah, this can work. Think that can work. So I know that I want the distance, how far due south it is. And where is that? That means I want this distance here. If I call this S, S for south, then this is the distance that I want, HS, right? So now we know what we want. We need to figure out how we're going to get it. So how we're going to do that? How we're going to find out that length? What do we know? If you realize, if you notice here, we know that this is a straight line. Yeah. And what do we know about straight lines again? What do we know about angles on a straight line? They add up to 180. Very good. And we already know most of it. We already know this entire part. We already know that all of this is 151. So to get the rest of it, we would just need to subtract this little piece here. Subtract this little piece from subtract 151 from 180 to get that little piece. Everybody with me so far? You seen that? So that's the property that we use for this one. So that means our angle, since I called down here, so S, I can say that SHR, angle SHR is going to be equal to 180. Should I say no? No. SHR is equal to 180 minus 151. And 180 minus 151 is 29. Yeah. All right, good. So now I know that this little angle in here, so, is 29 degrees. I know that I was talking about the distances south and all of those wonderful things. So we know that in that case, we're dealing with the south. And if you're looking at it from here, this would be a right angle because R is like R is looking across to the south line. Follow me? So if we here, you notice that we have a right angle and we want the length HS. How could we figure that out? Let's look at all of what we know already. We know that this side is 242. And what is that? That is the hypotenuse. So we know the hypotenuse is here. We know our angle is 29 degrees and we want HS. Which side is HS? Which side is HS? Is it the opposite or the adjacent? Which one? Look at where the angle is, and sometimes this gets students too. Look at where the angle is. Is it adjacent to the angle or is it opposite to the angle? Because this one, and that's why I wanted to highlight this one too. Because I see some people saying opposite, some saying adjacent, but let's look at why it is not opposite. Think about the angle. The angle is right here. See? So that means this side over here, so it's on the angle, it's beside the angle, it's adjacent to the angle, because that's what adjacent means. So adjacent means it's beside it, all right? So yes, HS would be the adjacent side. So now we have that information. We have a side, we have an angle, and we want to find the other side. Let's use our trig ratios. So We want the adjacent and we have the hypotenuse. What ratio links adjacent to hypotenuse? Let me see what you guys thinking. Which ratio link adjacent to hypotenuse? Is it what? Is it sine? Is it cosine? Is it tangent? What is it? Yeah, right. It's cosine. Good. So remember the cosine of an angle is equal to the adjacent over the hypotenuse. So our angle is 29. Our adjacent side is HS. We just call it that. And the hypotenuse is 242 kilometers. So that means HS, we multiply both sides by 242. HS is going to be equal to 242 times the cosine of 29. And now when you put that one in a calculator, 242 cos 29, what do you get? 242 cos 29. I think I get something close to, let's work it out here. 242 cosine 29. All right. So I'm seeing, oops. So I'm seeing some people saying 211, 212. Yeah, I got 211.65 something. And now looking into it, I'm not seeing it. It didn't specify how much you should round it to or estimate it to. But because the previous one said to the nearest kilometer and the lengths are in kilometers, I'm going to round it to the nearest kilometer too. So I'm just using a little context to help me know what to round it to. So that would be 212 kilometers. Now we know what it is. We need to pretty it up, write it out properly. So we can say, therefore, shape R is 212 kilometers due south of the harbor H. Right? Yeah. So that would be our final answer. And this question was worth 3 marks. This part of the question was worth 3 marks. I think the one up here so was 2 marks, and to complete the diagram was 1 mark. So that is how we could have solved here, right? Everybody good so far? Everybody clear? Not hearing from some people on YouTube though, you know. I don't want you guys to just be watching, you know. If there's something you miss, just let me know so we can make sure so you get it. You understand? Let me hear what you sound good. Everybody sound like them good. All right, good. So guess what, guys? This is the last question we're working for today. We're done. We shall look early. We never reached the hour yet, but that's fine. So remember the main things that we know for bearings. We need to know our angle properties and our rules, and we need to know when to use them. So always keep that in mind. Co-interior is one that it's kind of popular. So I would say make sure that you know that one. Co-interior angles sum to 180 degrees. So with that being said, of course, you know, you can get some more practice if you're a camper at my math camp. This one is for you guys. Next week, we're going to be looking at vectors and get this on yellow. Next week, we're going to be looking at vectors and matrices. So get yourselves ready for that one. We're going to do vectors Saturday, matrices Sunday. Is it our last session? Well, that was the plan, but if you notice on our WhatsApp page, we put out a little, on our YouTube page, put out a little poll, and a lot of persons wanted to look at circle theorem too. So I'm thinking that we're going to do some more. We're going to probably do another session or two before the exam. And then I think definitely, depending on how my schedule stay and what we can do, we could even probably do a marathon, like a paper or something like that before the exam. Not sure still. I'll make you know. But yeah, the two we're going to do is circuit. Well, when that poll finish, Circle theorem. Paper one. I was thinking about paper one, you know. Well, we could do something like that. What? Yes, the paper one gonna make you feel. Well, I know paper one kind of repeat mostly, you know. Repeat as in, even if it's not the same exact question, the questions are like really similar. So, you know, we probably can do something like that. During the week, looking in the chat, during the week, it won't work for me because I have classes every day. Monday, Tuesday, Wednesday, Thursday, Friday. So it kind of rough on my time. But as I said, that last week before CXC, I'll probably have to make some time just to make sure that everybody good. All right. For those, by the way, speaking of classes, for those who come to our regular classes, you know, tomorrow, we continue the same way because we're going to be looking at paper one in online classes. But for YouTube, we see what we can do for the paper one. Hopefully the time work out good. I say, Michael, don't say 40, 39 good. All right, boss. I hear you. All right, everybody, take care. It's good to see you all today, and I'll see you guys next week, Saturday at 5. Remember, study. Make sure I say you study. Make sure I say you prepare, and you will be good to go.